Recall, to simplify 7 squared, use 7 as a factor 2 times. 7 squared equals 7 times 7, which equals 49. But what does it mean for an exponent to be negative or 0? You can use a table and look for a pattern to make a conjecture. Let's take a look at this table. 5 to the 5th value, 5 to the 4th value, 5 cubed value, 5 squared value, 5 to the 1st value. If we're looking at the values, what would we do to this initial value to get the second value and follow that particular pattern? And this would be dividing by 5. Therefore, 5 to the 0 must be 5 divided by 5, which is 1. Followed by 1 divided by 5 is 1/5. 1/5 divided by 5, well, we'll need to use KCF, keep change flip. 1/5 divided by 5, remember, since 5 is a rational number, we can write it as a ratio of two integers. 5 is the same as 5 over 1. Now we will keep the first one just like we see it. Then we'll change the division to multiplication. And then we'll write the reciprocal, that's flipping it. And now we can multiply. 1/5 times 1/5 is 1 over 25, since we multiply the numerators and we multiply the denominators. 1 times 1 is 1, 5 times 5 is 25. Now by looking at this particular pattern, we should be able to see, hey, we have 5 to the negative third. What does that be? So notice 5 to the first was 5, 5 to the negative first was 1 over 5. 5 squared was 25, 5 to the negative second power was 1 over 25. 5 cubed is 125, so 5 to the negative third power would be 1 over 125. We must understand that when we see 5 to 0 power or any number to 0 power, what we're actually looking at is we're dividing that number by itself. So when we see 5 to 0 power, think about 5 divided by 5, and that's why the result is 1. It doesn't matter if the number is really big. 1024 to 0 power is also 1. It doesn't matter if the number is a fraction. 3/4 to the 0 power is 3/4 divided by 3/4, and anytime you divide a number by itself, you'll get 1. It could also be negative. Negative 9 to 0 power is 1. Be careful, because this is read as negative 9 to the 0 power. This is actually read as the opposite of 9 to the 0 power. So when we simplify this, you must think of it as the negative is outside. So the 9 is raised to the 0 power, but the negative is outside. So this is going to be the opposite of 9 over 9, which is negative 1. So you are not getting the same thing. Now let's take a look at 0 to 0 power. So this means 0 divided by 0, which is undefined. So any non-zero number raised to the 0 power is 1. The only time you have to worry about it is when you have 0 raised to the 0 power. This is what Siri has to say about 0 divided by 0. Hey Siri, what's 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And your friends are sad because they don't exist. Oh wow, this escalated quickly.
Any non-zero number raised to the 0 power is 1. So if we ever were to see 0 raised to the 0 power, it would be undefined. If we were to have 0 to the negative 4th power, the way we will simplify this is by multiplying it by 1. Anytime we multiply 1 times any number, the result is that number, since 1 is the identity element for multiplication. When we have a negative exponent, all we have to do is bring it to the denominator, and now it becomes a positive exponent. So it just changes sign. Now 0 to the 4th again is 1 over 0. And again, we can't divide by 0. It's undefined. Since division by 0 is undefined, neither value exists. So 0 to the 0 power is undefined, as well as 0 to any negative power. A non-zero number raised to a negative exponent is equal to 1 divided by the number raised to the opposite positive exponent. When we see a problem like 3 raised to the negative fourth power, remember we're going to write it as 1 times 3 to the negative fourth power. And now we could just write 3 to the negative fourth. We're going to bring it to the denominator and change that negative exponent to the opposite, which is a positive 4. We know that 1 over 3/4 is the same thing as 1 over 3 times 3 times 3 times 3, which is 1 over 81. Let's simplify. So again, first step, we're going to write it as 1 times 2 to the negative fifth. Second step, we're just going to bring the 2 to the negative fifth to the denominator, changing that negative exponent to the opposite, which is positive in this case. 1 over 2 to the fifth is the same as 1 over 32. Next, we're going to write 1 times negative 9 to the negative third. We're going to bring negative 9 to the negative third to the denominator, writing the opposite exponent, which would be a positive 3, which is equal to 1 over negative 9 times negative 9 times negative 9. Or you could simply know that the exponent is odd. So anytime we have a negative base and an odd exponent, the result will be negative. Therefore, 1 over negative 729. Or we can write it as negative 1 over 729, or negative 1 over 729. These two ways, the two bottom ways, are most likely the way you're going to see it if it's a multiple choice answer, but this first way is also equivalent. So any one of these three will get you the right answer, but most of the time you're going to see it as the last two. 6 to the 0 power is equal to 6 divided by 6, which is 1. The opposite of 0 to the 0 power, multiplied by a negative 1 in this case, because it's the opposite. And this would be negative 1 times 0 over 0. And remember, we can't divide by 0, so therefore it's undefined. Negative 6 to the 4th power is equal to 1,296. Remember, you just have to look at that even exponents. If we have a power whose base is negative and it's raised to an even power, the value will be positive, because negative 6 times negative 6 times negative 6 times negative 6, since we have an even number of negatives, we know that we're going to have a non-negative answer. In this case, we have the opposite of 6 to the 4th power. So in this case, when we're writing the opposite, we're going to multiply by a negative 1, not just a 1. So now 6 to the 4th power, we already know that's 1296. A negative 1 times 1296 is negative 1296. So the opposite is negative 1296. So again, we read this one as negative 6 to the 4th power. This one is read as the opposite of 6 to the 4th power. We have the opposite of 10 to the negative 4th power. We'll rewrite this as negative 1 times 10 to the negative 4th power. Since the power has a negative exponent, we'll bring it to the denominator. Now this power will be positive. So we'll have negative 1 over 10,000. We can also see it as negative 1 10,000ths or 1 over negative 10,000. Let's evaluate. When we take a look at m to the negative 3rd power, the first thing we want to do is use parentheses. Now we can substitute 7 in for m. We'll rewrite this as 1 times 7 to the negative 3rd power. Since the exponent is negative, we'll bring it to the denominator, and now we'll have 1 over 7 cubed, which is 1 over 343. Another way of doing this is to simplify the expression before evaluating the expression. We'll just bring m to the negative 3rd to the denominator. Now this expression is simplified. Now we can substitute our values in, and now we have 1 over 343. In this particular case, we'll begin by using parentheses. We'll substitute negative 4 in for m and 3 for n. Since both exponents are negative, we'll bring both to the denominator, and now our exponents are positive. Negative 4 cubed is negative 64, and 3 to the 1st power is 3. Remember, since our exponent is odd and our base is negative, our value will be negative, which will give us negative 2 and 1/92. In this particular case, the negative could be with the numerator or denominator, but usually we have it out to the left. Another way to evaluate this is to simplify the expression first. followed by evaluating by substituting our values in, and then simplifying. Okay, in this case, we have only one exponent that's negative, so this will go to the denominator as a positive exponent. N to the 0 power we know is 1 as long as n is not 0. 5 times 1 is 5. So our answer is 5 over m cubed. The next one, we have a negative exponent in the numerator and a negative exponent in our denominator. Therefore, m to the negative 4th will go into the numerator with a positive exponent. N to the negative 6th will go to the denominator with a positive exponent. And that's it. That's our answer. In this particular case, we have a negative exponent in the denominator. So therefore, m to the negative 2nd will go into the numerator as a positive exponent. Our expression is now simplified, negative 5m to the 7th.